Hi guys, today we're going to be looking at the second example under the third series of examples on projectile. So look at what we have here. A body is projected downward at an angle of 30 degrees with the horizontal from the top of a building 170-meter high. Its initial speed is 40 meters per second. How far from the foot of the building will it strike? Now that's the question we have right here on the board. There's a second example under the third series of examples. So the first thing we have to do is we have to look for a way to get a pictorial interpretation of this very question. So we're going to try to do that. So don't forget, a body is projected downward. It's not the body is not projected upward like the other examples we've looked at. But this time, the body is projected downward at an angle of 30 degrees with the horizontal. So here's the building. You have a building like this, and somebody stands here and project this body downward like this. So this body was projected downward at an angle of 30 degrees with the horizontal. Angle of 30 degrees with the horizontal. So that's what we have here. The initial speed is 40 meters per second. Now it was done against the horizontal, which is 30 degrees angle. So the first thing we're going to get is we're going to get a component of, we're going to get the component of the initial speed. The body was projected 40 meters per second at an angle of 30 degrees with the horizontal. So we're going to get the component of this very initial speed. So let's do that first. This initial speed along x, initial speed along y, this 30 degrees here. We have the same thing here, 30 degrees. So opposite right here, hypotenuse, right, this is adjacent. So there's it here. Initial speed along the y-axis over 40 meters per second, which is the main speed itself, is sine 30 degrees. So uy is 40 times sine 30 degrees. So initial speed along y-axis is 20 meters per second. Sine 30 is 0.5 or 1 over 2. So 1 over 2 times 40 is 20 meters per second. So initial speed along the x-axis is 40 times cos 30 degrees. Our calculator could help us with that. 40 meters times 0.8660. 40 meters times cos 30 degrees. That'll give us 34.64 meters, 34.64 meters per second. We've gotten that already. So now the question is how far from the foot of the building will it strike? Now here we can use our range, but this looks very much like range, but this is not range we're talking about, because for us to talk about range, it means you're going to have something related to maximum height and so on. But here we're going to be using our trajectory. Don't forget the formula for trajectory. Don't forget it. The formula was derived from s equal to ut plus f at squared. That's where the formula was derived from. So we're going to be using that. So don't forget that the distance along the x-axis will give us u cos theta, which is initial speed along the x-axis times time. So we end up having u cos theta dividing both sides. U cos theta. So our time, which is time mainly along the time for everyone, actually with x and y axis, there's a time. So for the one along y, we're going to have ut, which is distance times tan theta, plus 1 over 2 gravity. Gravity could be positive or negative. It depends on if the body is projected down or projected upward. Then times rgt squared, that's rpt squared. So the time is distance squared over u squared cos squared theta. This is our formula. This is what we're going to be using. Now, the fact is, this building is 170 meter high. This is a 170 meter tall building. So right away, we know the distance along the y-axis to be 170 meter. So the angle of projection, is 30 degrees. So what we have to get is the distance along the x-axis. That's what we're about to get. So we're asked to get how far from the foot of the building it will strike. How far this very object that's projected from the top will strike from the foot of this very building. That's what we're asked to get. So how far from the foot is it going to strike? So it's very simple. We have this distance along the y-axis already stated. This is what we are looking for. Just this. So the distance along the y-axis is 170 meter. Then distance along the x-axis is what we are looking for, times tan 30 degrees right away, as you can see that, plus 1 over 2. Now, this body was projected down 30 degrees to the horizontal. It means gravity has been obeyed. Gravity will be positive times 10 meters per second squared. Then times the distance we are looking for. We are looking for the distance along the x-axis over what do we have? Initial speed is 40 meters per second. So it's 40 raised to power 2 times cos 30 raised to power 2. That's what we have. Cos 30 raised to power 2, that's cos squared theta. So the next thing we're going to do, we're going to take out this portion and keep solving up there. So let's do that right away. Take out this. So what do we do next? So we open up the whole thing. 170 equals 2. So distance times tan 30. What is tan 30? Let's look at that. Tan 30 will give us, let's see what that will give to us. That'll give us 0.57735. That'll give us 0.58. Let's use that approximately to 2 decimal places. Plus 2 year 1, 2 year 5. So you have 5 times distance along this squared over 40 raised by 2 is 1600, 1600. Then cos 30 is root 3 over 2 raised to power 2. You know what that will give to us? So that's 170 right here, 0.58 distance that's along the x-axis. Then 5 distance along the x-axis raised to power 2. Then 1600 times root 3 over 2 times root 3 over 2. That's root 3 over 2 times root 3 over 2. Root 3 times root 3 is root 9, which is ordinary 3. 2 times 2 is 4. That's 3 over 4. 4 year 1, 4 will divide this 400. We're very close to what we want, close to getting the distance along the x-axis. We're very close, very close. So what do we do next? The next thing we do here is this 400 times this. So we can even divide 5 here 1. 5 here we have 80. So that's 170 equals to 0.58 distance along the x-axis. So distance along the x-axis raised to power 2 over 80 times 3 is 240. That's that. 80 times 3 is 240, I mean. So over 1 over 1. The next thing we're going to get our LCM. Just finish up the whole thing. You get our LCM. That's the next thing we're going to do. So 240. The LCM is 240. So 240, 1 in 240, 240. 240 times 1 times 170. 240 times 170. We give us 40,800. 40,800. Then equals to 1 in 240 is 240. 240 times 0.58. 240 times 0.58. You give us 139.2. 139.2 distance along the x-axis. So 240 times this, we're going to have distance along the x-axis, which about 2 left. So this goes out because we're talking about LCM. Once we have, we're talking about an equation. Once you have an equation, the LCM goes off. So what do we have? We have distance squared plus 139.2 distance. Send this to the other side, minus 40,800 equals to 0. So at this very point in time, we can use our calculator to solve this to get the values of x in order to save our time. And we can also use, can decide to use whatever method. You can decide to use the formula method, minus b plus or minus squared of b squared minus 4ac. But that's going to take quite a lot of time. So we can use our calculator to solve this. So the first, we have 1 there. The next, we have 139.2. And the very last one, we have minus 40,800. So what are the results? You have 144 and minus 283. So the values of the distance, we have 144 meter, 144 meter, or minus 283, but we don't need the minus 283 meters at all. We don't need that. So this the distance the body falls, it falls at 144 meter away from the foot of that very 170 meter building. It's as simple as ABC. Now, there's another method we could use. You could decide to use the, you could decide to use another method, but I think this is fine. As simple as that. So that'll be all for now.